In this video we're looking at a new word. I think it's quite new. For you is the word the discriminant, and it's symbolised by a triangle sign. Whoops, let me find my pen. A triangle, which is the Greek delta, D, letter D for discriminant, and you'll recognise that the equation to find the discriminant is b squared minus 4ac, which is part of our quadratic formula. So we're just working out part of the quadratic, this b squared minus 4ac, which is going to tell us what kind of roots the quadratic has. Okay, it's the nature of the roots of the quadratic equation. So when you have your graph like this, we had two roots here and here, didn't we, where they cut the x-axis. Sorry, I marked them in red there. We had a root here and a root there. But we could also have a parabola that is up here, and that doesn't have any roots. It doesn't cross the x-axis, and it may have imaginary roots. Okay, we get into the realms of imaginary, or it could be a quadratic that like that, and it just crosses in one place. It has a repeated root, or two roots the same, which are one root. So that may be the case too. In this case, our triangle here, our discriminant equals 0 in this case. Here, our discriminant is a negative number, okay? Our discriminant is going to be less than 0. And in this case, when we have two roots, our discriminant is going to be greater than 0. So by working out this value, we know kind of what the graph is going to look like, and the number of roots and the type of roots. So let's do an example here. We'll do 3x squared minus 4x plus 5 equals 0. Now this is I need to label my A, my B and my C. So from that I know my discriminant equals B squared is negative 4 squared is 16 minus 4 times 3 is 12 times 5 is 60. Okay. So my discriminant equals 16, take away 60 is negative 44. Because this discriminant is negative, I can say that it has no real number, real roots. Okay, only imaginary, really. Okay. Another example. Let's have a look. We're going to another. What about if I'll give you some examples. My discriminant worked out to be 49. It has two rational roots. Rational roots, you would write. They can be written as fractions because 7 sevens are 49. This is a perfect square, right? 7 sevens are 49. If it has two roots, and for extra, probably for merit, then we could also be saying that they're rational. If my discriminant came out to be 20, I have two roots, and we can say that these are irrational because this is not a perfect square. What about if my discriminant worked out to be 0, I would say it had one repeated root, or one rational root, one repeated root, or one rational root. If my discriminant worked out to be -5, I would say it had no real root. No real root, only imaginary. Okay, what about if the discriminant was 97? Okay, 2 irrational roots. If the discriminant was 100, now 10 times 10 is 100, so in that case it would have 2 roots, but they would be rational roots. They would work out to be fractions, rational roots. Okay, now sometimes the questions, I think these often are, if I had 3x squared minus 4x plus q equals 0, and I'm told that this has 2 real roots. Find what the value of q could be. So I know from my discriminant, this gives it away that I'm looking for the discriminant. When it tells me it has 2 real roots, or they may say it has no real roots, we know we're talking about the discriminant. And so when I look at this, I know that if it's got 2 real roots, b squared minus 4ac must be greater than 0. And my b value I have here, okay, and my a is 3 and my c is q. So b squared 16 minus 4 times 3 times q is greater than 0. So 16 minus 12q is greater than 0. I don't like my minus 12q, I'm going to put that on the other side and change it to a plus 12q. 16 is greater than 12q. Get rid of my 12, divide by 12 on both sides. So when 16 divided by 12, that's 4 over 3. Q must be less than 4 over 3 in order to have 2 real roots. Okay, that's my value of Q. And that's our video on the discriminant. Thank you.